So these are the log laws that I was talking about before. So it's really important to have this somewhere in your notes, definitely, because especially having it in your exponential section of your notes, I find it's really helpful because you can like flip to it, refer to it throughout the year as well. And just having a concise section of them really makes life easier. So if you want to take these log laws or just take it from the formula sheet or find the ones on the formula sheet and then supplement them or take it from your textbook, it's kind of up to you, but I would say definitely have a copy. Okay, so let's kind of chat through the log laws. So if we have m to the power of something, what we're going to have is just p times log am, and that kind of just relates to the third law there, log am plus log an equals to log am times n. So if we imagine m times m times m times n to the power of p, so if we imagine kind of log am times m times dot 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 m, and there was p times of m in there, so like p times of m being squared, i.e. m to the power of p, then what we would have here is, if we try to separate that, it would be log am plus log am plus log am plus log am, and then onwards from there until we kind of reached p of that, so we can just times it out, and that's how that kind of law was derived in the first place. So what happens here is how this actually works is when we minus powers from each other, so when we have e to the power of 3 minus 2 or e to the power of 3x minus 2, what that actually means is just e to the power of 3x times e to the power of negative 2, right? Or otherwise known as e to the power of 3x over e to the power of 2. So that's exactly how it works here. So when we minus powers, what we do is we're dividing the products of them. If we're timesing powers, what we're doing, if we're plusing powers, what we're doing is timesing the products of them. So timesing the outputs of them. And this rule is derived from, I guess you can say it's derived from this rule or from this rule, because either way it's the same. So 1 over m would just, you can either write that as log a1 minus log am, or you can write it as log m to the power of negative 1, and it's going to give you the same thing. So if we follow along with this rule, so log am, m to the power of negative 1, pop the negative out the front, or we can follow this rule as well, so that's log a1 minus log am. Log a1 is just 0, so it's just going to equal to negative log am, and log a1 is 0. So just like e to the power of 0 is 1, log e1 is 0. And if we look at the graph, that's also what we kind of figure from there. So that's the position. Cool. Alright. Another important rule that's often used quite a lot is the change of base rule. So the change of base rule is essentially, like the name suggests, a rule that's useful for changing base. I haven't seen it used that much like in isolation, because normally log questions, especially in exam 2, they're like in combination with differentiation and stuff. But I can say that it will definitely be helpful in terms of differentiation and integration, just because you actually can't differentiate a non-natural log. So you can't differentiate 2 to the power of x just by itself. You actually need to convert its base to e of x before you can do it. So kind of keep that in mind a little bit. Cool. So there's kind of this is the main change of base law. So how I like to think of it is the a goes at the bottom, the x goes at the top, and then you just put whatever base you want here. So it's kind of like ax, so ax over a, right? And then if we just wanted to flip which one was over which, right, all we have to do is just kind of just change it to 1 over that. Alright. Okay. So let's chat about this question a little bit then. I feel like this question's a good question considering it's a big question in the first place, which is always very exciting. So let's kind of talk about how this works. So the expression x the expression log xy plus log yz, where x, y, and z are all real numbers greater than 1, is equal to, and then we need to kind of consider what we're choosing from there. So the first thing that we kind of can notice from this question is that there is a changing of bases throughout this question for most of these, right? So we have yz here, yz here, yz here. Okay, so the only two which don't have the change of the base is these x and y, x and y. So first what we can do is kind of rule out or rule in those ones first to kind of consider whether those ones are correct or not. So log xy plus log yz, is that equivalent to 1 over log xy plus 1 over log yz? And if we have a bit of a think, we realize no, it's not equivalent, because if we're like, we can kind of get tricked. So this is kind of just bringing up the thing of log y 1 over z is not equivalent to log y z all over, so 1 all over that. So just keep that in mind when you're, just be careful about that. But essentially it's not equivalent because we're flipping the two, but we don't really know what's equivalent to on the other side. And even if it was equivalent, the plus would need to be at the bottom down here. So no, it's not equivalent. And in the same manner, this one wouldn't be equivalent either because we're just adding negatives out the front. It's the exact same thing here. Okay. Now we need to consider the changing of bases, right? Because we've changed our bases for all of these. So what we're going to do here is now try and change the base. So we're going to pop the y at the top, and we're going to try and change it so we need y and x to be together. So we might as well just change the bases all to y here. So we have log y over log y x, and we could have used the second rule here, but if we didn't remember it, we can use this one, plus log, then this one has z here and we need z there, so we can do z over log z y, right? So log z over log zy, so that's just going to give us 1 over log yx plus 1 over log zy. Cool. So we kind of already know that this one is the correct option, but we can always check. So once again, it's just negating the whole process. So even though this is true, this may not be true, right? Because even if this is true, that's timesing everything by -1. And if we times everything by -1, it might not necessarily be true anymore because we've times by -1, so therefore we've changed the result slightly. And this one, once again, just like how we couldn't flip this one into this one, we also can't flip this into this. So kind of rule those out.